In this video, I introduce FixMatch, consistency, and confidence for semi-supervised learning. Semi-supervised learning uses a small portion of labeled data and a large amount of unlabeled data to improve the model performance. FixMatch combines consistency regularization and pseudo-labeling into semi-supervised learning, which further generates pseudo-labels using the predictions on a weakly-augmented unlabeled data, and then use the pseudo-label as a target to predict the strongly augmented version of the same data, whereas the pseudo-label is only the label with the probability above the threshold in the weakly augmented data predictions, as shown here. This unlabeled input data, this weakly augmented input data, and this strongly augmented data. This is a model. First, we use the model to generate prediction. The label above the threshold is used as a pseudo-label to train the input with a strongly augmented method. Then now we use cross entropy to train the model for the semi-supervised learning. A weakly augmented data is fed into the model to obtain predictions. When the model assigns a probability to any class that is above the threshold, the prediction is converted to a one-hot pseudo-label. Then the model predicts for strong augmentation of the same data. The cross entropy is applied to train the model to match the predictions for the strongly augmented version of the pseudo-label. X is a batch of B-labeled examples, where XB are the training examples and PB are one-hot labels. U is a batch of mu B unlabeled examples, where mu is a factor that determines the relative sizes of X and U. PM is a predicted class distribution produced by the model for input X. Consistency regularization assumes that model should output similar predictions when the model is fed with private versions of the same data as shown in here, where both alpha and PM are stochastic functions, so that the two PM will generate different values. Pseudo-labeling leverages the model to obtain artificial labels for unlabeled data. For example, using pseudo-label in QB, the loss function becomes here, where PB caret generates a one-hot probability, and tau is a threshold. Supervised loss LS on weakly augmented labeled examples XB is defined as here, where PB is a true target on the label data. Unsupervised loss LU uses cross entropy H to minimize difference between the predictions PM on unlabeled data and the pseudo-label QB caret as shown here. The overall FixMatch loss is defined as sum of two terms, where lambda u is a factor to balance the relative importance of the unlabeled loss. Description of the FixMatch method is shown here. For more details, please check with these references. Thank you. Bye.